Welcome to part 6 of Computer Programming 1. In part 5, we took a look at our first programming assignment and we looked at what methods are and how to implement them to satisfy our programming assignment. Once again, I have to remind you that there's not a starting point in learning object-oriented programming. Just about everything that we do has some dependency on something else, which is kind of strange. But nonetheless, methods are one of those things where we're on the outside of the carousel now looking at a summary, and we're about to get a little more specific. We have in other words, we have a chicken and the egg problem. Which comes first, the method or the method call? They both work together, and we have to learn one of them first. So, in our last session, we created a method called go in the class called vehicle. And we also had a few methods that we call getters and setters. So I want to take a moment and describe in more depth what these are. So in this presentation, we're going to talk about methods. Then we're going to talk about how to call methods from one class when we're in another class. Just a reminder, as I'm going to go to the Projects tab here, we actually have two different classes here, one named Driver and one named Vehicle. That's very important, two different classes. It's also important to realize that we have two classes because they do different things. The class called Driver interacts with the user. It's a user interface class. The class named Vehicle is a noun class that represents a vehicle, and a vehicle can have state. If you think right now how many gallons of gas in your car are in your car, that you're describing your vehicle's state, the gallons of gas. If you think about what the odometer reading is on your car, it's part of your vehicle's state. Let's say you bought a Chevrolet Cavalier in 1997, and right now it has 100,000 miles on it. That's unique to your car. The other Cavaliers that you see in the street probably don't have exactly 100,000 miles on it. Even if we did find two that had exactly 100,000 miles on it, they would both have different vehicle identification numbers, and they would both have different license plate numbers. This is what defines the state of an object. So your Cavalier and your neighbor's Cavalier are both Cavalier objects, and they both have the same attributes, but those attributes have different values. In other words, an attribute is odometer. The value for your odometer attribute might be 100,000, but the value for your neighbor's odometer attribute might be 60,000. These are the kind of things that we are going to represent in our Java programs, and we represent them with special variables called attributes. So these are the attributes here. And by the way, just so you know, I'm going to talk about attributes, and then I'm going to talk about the getter and setter methods that go along with them. So I know I started talking about methods. Trust me, there's a point, and we're getting back to methods in just a moment. In any case, these are our attributes that describe a vehicle. We haven't given them value yet, but note that an attribute is a variable, and variables get declared. Declaring a variable requires two things. It requires a unique name that follows the Java naming conventions. Here we have odometer, miles per gallon, and gallons of gas. These are three different variables. We also have to have a data type, and the data type tells us when we have this place in memory, what do those zeros and ones represent? So variable name will allocate a variable name will address a specific place in memory. The variable type says how big that place will be in memory and how many bytes, the variable type will tell us how big it is in memory in bytes and what to do with those bytes. How do we interpret those zeros and ones? Do we interpret them as a 10 base number? Or do we interpret them as a 10 base number and then convert that to a character? Or do we use a 10 base number and then convert it to a color? So on and so forth. So the variable type tells us how we are going to deal with the zeros and ones that are in memory for each of these variables. Now, we have here three different methods, 1, 2, and 3. And methods, just like variables, have to have a name. And that's what we see here in black. We see the name go, get odometer, and set odometer. That's a method name, and that's how we call a method. We also have to have a return type. Void means we don't return anything. Int means we return an int. Double would mean we return a double, so on and so forth. By return type, what do I mean? I mean when a method finishes doing its work, it might return a value to the place where it was called. Now, we don't really know what calling a method is yet, so that's kind of a tricky concept. But notice here, int get odometer is returning the value of the odometer attribute. So we're saying that when this method is called, it is going to return this value, the odometer value. On the other hand, a void type means it doesn't return anything. The method just finishes and it's done. Now, in the parameter, another part of a method signature, and by the way, this entire line is called a method signature. Another part of a method signature is a parameter list. We know now that methods can return values. They can also accept values. So in this case, the method setOdometer is accepting a value called inOdometer, okay? And it's assigning that value to the odometer attribute, like so. Okay? It's very common to have this syntax where we'll have an attribute like this one named odometer, and then a getter and setter method for that attribute. That's what we call encapsulation. If this is your field of choice, if you want to be a programmer, this is an important term to remember because it's one that you'll be asked in an interview. I've asked it in many interviews, and I have been asked the question in many interviews as well. Encapsulation means make the attribute private, which means it's only visible within this class, and then invoke it through getters and setters. Make it available through getters and setters. That's what we call proper encapsulation. This method here, the method called go, is just what we would call a work method. And a work method just does some kind of work. In this case, what we're going to do is we're going to travel a certain distance, and we are going to change the odometer to reflect that distance traveled, and probably also change the gallons of gas. Now that we know a little bit about methods, I'm going to go back and look at the PowerPoint from the book that tells us access specifier, such as public. These are parts of a method. Access specifier tells us who can call this method. Return type tells us what type of data it will return. Method name is a unique name that we can decide. It has to adhere to the naming conventions, but it's a name that we can decide. A list of parameters, and then the open and close curly determines the boundary of that method. So the go method is this area bounded by the open and close curly. Get odometer, this area. Set odometer, this area. So there we go. Vehicle is a noun. The state of the noun is described by its adjectives or attributes. Odometer, miles per gallon, gallons of gas. It has methods that represent verbs, and because these are public, they can be called externally. In other words, from an external class. We'll come back and explore this concept of encapsulation in a minute, but first I want to show how we can interact with the user and create a vehicle and create a vehicle state. I'm going to go to the Projects tab and I'm going to click on Driver. Driver, remember, is our class that's going to interact with the user, and if we remember where we left off, the method called main is where this program is going to start. This main method then invokes the prompt user method. In the prompt user method, we're going to ask the user for some details. Before we do that, though, let's try and interact with our car. So remember, we have our vehicle and our driver. Let's have our driver interact with our vehicle. This is a bit tricky, and a lot of people get confused on how to do this. But what we need to do is we need to make a variable of type vehicle. Wow, wait a minute now. What is vehicle? Vehicle is our other class. Remember, right now we're in driver. We're going to vehicle. So to make a variable, I need a name and a type. Okay. So the type will be vehicle. That's the type of variable. Vehicle. And then the name, we can call it anything we want. We'll say my vehicle. Okay. That will create a variable of type vehicle. Okay? Now what we need to do is we also need to assign something to that. So what I will do is I'll say new vehicle. This syntax is kind of funny. I say new vehicle, open and close paren, and then semicolon. The capitalization has to be the same as the class itself. So here we have vehicle with a capital V. It's very important that this capitalization on line 31 be exactly the same as what we see in vehicle.java. What we're doing here is called calling a constructor. Calling a constructor. In other words, what that's doing is that's creating a place in memory for a vehicle, okay, with all of these attributes and everything else that needs to be a vehicle. Why do we do that? Well, something we'll explore a little bit later is that we can have multiple vehicles, okay? If you think of something like a car rental agency, you go to their website, they have lots of different vehicles, or if you buy a car, you search vehicle inventory online, each of these would be a different object. But let's save that discussion for later. Right now, this is just one of those things where we're on our first summary around the carousel, and we know there's some things we don't know about yet, but we're surveying everything at a high level. Let's just say what we're doing with this line, vehicle, my vehicle equals new vehicle, is we are creating a variable of type vehicle, and vehicle is this other class. This will allow us to interact from our driver to our vehicle. From here, I have something very powerful I can do. I can say my vehicle dot set, and notice what comes up, set gallons of gas. Okay, as I type in set, we get set gallons of gas. I go ahead and hit enter, and we'll say, I'll just hard code in 25 for the moment. Then I can say my vehicle, and 1 second, it's frozen up, dot set miles per gallon. We'll say, actually let's say 25 miles per gallon, and we'll say 12 gallons of gas. And then finally we'll say my vehicle dot set odometer, and we'll say 25,000 for this. Okay, what we're doing here that's very important is we're taking these values from driver and we're passing them to vehicle. Okay, we're taking these values from driver and we're passing them to vehicle. These are two different classes. They have to have some way to interact, and this is how they're going to interact. Let's take, for example, set gallons of gas. You see here I've hard-coded the value 12. I've hard-coded the value 12 and set gallons of gas. Let's think about what's going to happen to that 12. That 12 is going to the set gallons of gas method. I go to vehicle, I look at set gallons of gas. That 12 is going to be assigned to what we call a parameter variable. It's called a parameter variable because it is part of the method signature. In other words, it's a parameter getting passed into this method. So this variable here, when we call this method from driver, right here, this variable gallons of gas is going to have the value 12. Okay? We're going to take that 12 and we're going to assign it to the attribute gallons of gas. So two different variable categories, let me say. We've looked at two different variable categories. One are attributes that describe the state of a class. Another is the parameter variables that allow us to pass information from a method call to a method. So this is a method call, my vehicle.set gallons of gas. This is the actual method that's getting called. Okay, so we're passing information into my vehicle. Okay, given that, let's make a new method. I'm going to make a new method. Well, we can put the method in any order. The order of methods in a class does not matter. They all have to be within the class itself, and they cannot be within another method. I'm going to make a method called public string to string. And what this is going to do is it is going, let me put some comment here, return a string that represents the current state of the attribute values of this object. Okay, public string toString, and I'm going to say string return value equals, and I'll put gallons of gas and then a colon in quotes. Because it's in quotes, that means it's a string literal, which means that Java should look at that literally as a string. It should not try to interpret that as if it's a variable. Then I'm going to concatenate by using the plus. I'm going to concatenate the gallons of gas attribute to that string. In other words, since gallons of gas is not in double quotes, Java is actually going to look and see what the value of gallons of gas is, and it's going to append or concatenate that value to the string literal gallons of gas. Then I'll have another plus and double quote, and we'll say odometer and a colon. Again, because this is in double quotes, Java's going to look at this as a string literal. It's not going to interpret it as a variable. Then I'll use a plus and then odometer. And because odometer is not in double quotes, Java is actually going to substitute for that whatever number odometer is storing. Notice that the string literals in double quotes are orange. The attributes are green. This is to help us visually tell them apart. Finally, I say return value. And this way I can easily find out what the value of my gallons of gas and odometer is at any time. And we save. Okay, now let's see how we can access this toString method from driver. I go back to driver, and I'm going to declare a variable of type string. I'll put this in comments. A variable of type string that will hold the state from the vehicle object. More specifically, let's say the myVehicle object. String myVehicleState equals myVehicle.toString. There we go. Notice what we're doing here. We're declaring a variable, because declaring a variable means we give it a name that's unique, in this case myVehicleState, and a type, and the type is string. Okay, that's declaring a variable. Initializing a variable is assigning an initial value to that variable. Here, we're calling the method myVehicleToString, and the equal sign means take what's on the right, evaluate it, assign it to what's on the left. In other words, call this method. When you call this method, it's going to return a string. Take that string that was returned and assign it to this variable, myVehicleState. After that, we can do a system out print line and say vehicle state, okay, plus myVehicleState. And there we go. Okay, I'm going to save this, and now let's see what happens. What I'm expecting is that this vehicle state should show gallons of gas of 12 and odometer of 25,000. So let me save, and then I'm going to right-click and choose Run, and let's see what we get. There we go. Vehicle state gallons of gas 12, odometer 25,000. Okay, and if I change this to 13, it would say gallons of gas 13, odometer 25,000. So you see what we've done here is now we're interacting from our driver class to our vehicle class. Now we're interacting between the driver and the vehicle. Okay? So the driver is providing values. They're hard-coded values, but they're providing values to the vehicle class. The vehicle class is receiving those values as parameters, assigning the parameter to the attribute. Okay? Again, declaration means name and type. Assignment involves an equal sign and means take the value on the right and assign it to the variable on the left. And then initialization is just a special kind of assignment. It's the very first time we assign a value to a variable. It's called initialization. So those are some key words for us: assignment, initialization, and declaration. Okay. So at this point, we're fairly certain we understand how this runs. what I'm going to do now is I'm going to change it. Now, if we hard coded every car to have 12 miles or 12 gallons of gas and 25,000 miles on the odometer, it'd be a pretty boring world because every class would be the same. Instead, what I'm going to do is I am going to prompt the user for information, which is the point of this method, to prompt the user for information. So, ask the user for gallons of gas. Okay, to do this, I have to use a class called JOptionPane. And the syntax here is really tricky. Capital J, capital O, PTION, capital P, ANE, dot show input dialog. Okay, how many gallons of gas? This, and then terminate with a semicolon. Okay, now JOptionPane is a library that we're allowed to use, but we have to tell Java where to find it. So I click the little light bulb here and I say add import for javax.swing.joptionpane. I'm just saying this is a Java library that I want to use. It happens to be a library that will post a dialog box where the user can type some data. So now I'm going to save and I'm going to run again, and let's watch what's different about the program this time. How many gallons of gas? Let me say 15. Take a look at that. It now has sent up a prompt box and it's asking me for information. I'm saying 15 gallons of gas, so I choose OK. Unfortunately, though, our vehicle state does not change. Our vehicle state still says 12 gallons of gas. Reason being, we've hard-coded this value 12 and we're passing that into set gallons of gas. Okay, we need to change that, and instead of hard coding 12, we need to use whatever the user asked for. Well, this method showInputDialog happens to return a string. It has a return value, and that value is a string. So what I can do is click on the light bulb on the left and say assign return value to new variable. Yeah, you bet. And NetBeans will create an assignment here. I'm going to change this variable name from showInputDialog to str gallons of gas. Okay, and there we go. Now, when the user is prompted for a gallons of gas value, we're going to store that into the variable str gallons of gas. Okay, when the user is prompted for a gallons of gas, we're going to store that into the variable str gallons of gas. Now we have a bit of a challenge here. We only assume that the user enters string data. If I were to try to take this value and pass it to set gallons of gas, I would probably be disappointed. str gallons of gas. I get what we call a red line or a syntax error, and let's take a look at what it says. Required double found string. So you see this is a string data type. String is alphanumeric, so you can enter alphabetic characters and numeric. But set gallons of gas, on the other hand, expects a double, and a double is strictly a numeric data type. We cannot switch the two this easily. We can't just dynamically change their values. What we have to do is we have to convert the value the user entered from string to double. Okay, you'll need this in programming assignment number 2. As a matter of fact, most of what I'm going over right now is going to have a very close relation to programming assignment number 2. So what I'm going to do here is I'm going to declare a new variable of type double, and we'll call that dbl, gallons of gas. And then I'm going to say capital D double dot parse double str gallons of gas. This is just some syntax to remember. I mean, kind of like learning a new language. You have to a new language to speak. You have to learn a little bit of syntax. This double dot parse double. Okay. The parse double method, we pass in a string and it returns a variable of type double. Okay. We pass in a string, it returns a variable of type double. So it converts. It converts from one data type to another. Remember my spreadsheet before when I talked about zeros and ones? Uh-oh, Excel froze up on me there. I talked about a computer speaks in zeros and ones, and we need to know how to interpret that. As a string, we're applying some kind of map, like our ASCII or EBCDIC or Unicode map, to take numbers and convert them to letters. Okay? But as a native double type, we actually mean we're going to take those zeros and ones and interpret them as numbers. But the string, double quote 25 double quote, may not be the same zeros and ones as the double value of 25. As a matter of fact, they're not. This double.parseDouble simply converts a string data type to a double data type. Put in a string, get out a double. That's all it is. Now with that, we can pass this double into set gallons of gas. GBL gallons of gas. There we go. And I'll say invoke the setter methods on my vehicle to set the state of the vehicle. One question might be, okay, why don't we just start with the double in the first place? Well, the problem is that wouldn't work. And we'll see why here. We get a red line, and remember, a red line we have to fix. This time it says, incompatible types, required double, found string. The reason we can't use a double here, we have to use a string, is this method showInputDialog only returns a string, and we can only store a string in a variable of type string. So you might think, well, gee, can't I just store it in a double variable right off the bat? No, you can't. You have to store it in a string and then take an intermediate step. That intermediate step is convert the string to a double and then send the double down to get gallons of gas. Now a follow-up question is, why don't we just make gallons of gas a string over in our class vehicle? Well, we cannot perform math on a string. Eventually we're going to figure out a go method where we're going to accept a distance and we're going to change the value of odometer and gallons of gas. But to change those values mathematically, they have to be raw number types. They can't be strings. By the way, since this is a recorded session, I'm more than happy to answer your questions via email. But again, this is a class I've taught many times, and I'm very much used to the questions that I tend to get at this point. So a lot of times I'm trying to answer questions that you might have just based on having been asked me having been asked them in previous courses. So these are typical questions that I get, which is why can't we just store it as a string from here? Because showInputDialog, I'm sorry, why can't we just store it as a double? Because showInputDialog is going to return a string. We have to be like types. This is our conversion. And then we pass that value into set gallons of gas. Given that, let's try again. Let's go ahead and run this file. For gallons of gas, remember that before we had it hard-coded to 12. This time I'll change it to 14, and I'm going to choose OK. And now we see, sure enough, the vehicle state shows 14. Okay? Sure enough, the vehicle state shows 14. Okay. Now what we can do is we can do the same thing for miles per gallon and odometer. Okay? We can do the same conversion for miles per gallon and odometer. So for practice, why don't we go ahead and do that? Okay. But you know what? Gosh, that JOptionPane, that is such a tricky syntax. I'll show you something now that you don't have to do, but it will save you a lot of time if you make an investment right now. One nice thing about NetBeans is that there are certain things that are configurable and customizable. One of them is you can make your own shortcuts. I'm going to go to Tools, Options, Editor, Code Templates. Again, Tools, Options, Editor, Code Templates. And of course, the nice thing about this being recorded is you can always go back and replay it if you wish and see this again. But Tools, Options, Editor, Code Templates. I'm going to choose New. For abbreviation, I'm going to choose JOP. Expanded text, I'm going to say capital J, capital O, lowercase ption. And by the way, spelling and capitalization is very, very important here. Capital P, lowercase a and e, dot show, all lowercase, input with a capital I, dialog with a capital D, and then I'll do open and close paren, open and close double quote. I just have to hit the open paren, it will give me the close paren. I just have to hit the open double quote, it will give me the close double quote. Now this syntax gets a bit tricky. I do $, open curly, cursor, the word cursor in all lowercase, close curly. I go to the very end and put in a semicolon. Okay, take a look at the syntax very closely if you're doing this yourself. JOptionPane.showInputDialog, open paren, double quote, $, open curly, the word cursor, close curly, close double quote, close paren, semicolon. Okay? Be very careful of that syntax and spelling. If you're doing this on your own, it's a good idea to pause right now, put this in one window, and then compare it to your actual NetBeans application. After I've done that, I'm going to go to the bottom here and choose OK. Now remember where that $ cursor is and watch what happens now. Okay? I'm going to hit enter a few times. I'm going to type JOP and I'm going to choose tab. Boom. See, what happened is I just made a keyboard shortcut. When I type JOP tab, it's going to automatically insert JOptionPane.showInputDialog. That's going to save me a lot of typing and a lot of errors because the capitalization is so goofy on that. So now what I'm going to say is how many miles per gallon. Okay, and I'll say string. We'll just say strmpg equals how many miles per gallon. Then I'll say double dblmpg equals, we remember this guy. Actually, no, that's an int, isn't it, for miles per gallon? Yeah. So I'm going to say int mpg equals integer dot parse int strmpg. What this does is this converts from a string to an int. An int is a data type that only holds whole numbers, but it's very efficient at doing that. So a double will hold fractional numbers, or numbers with a decimal. An int holds whole numbers. I'll put a comment up here. Prompt the user for miles per gallon. Okay. Now in set miles per gallon, instead of the hard-coded 25, I'm going to pass in the int equivalent of what the user entered. Okay. So these are the lines I've added, and this is the line I've changed. Okay. Set this value in the vehicle. Let's say my vehicle object. Okay. Finally, let's say prompt the user for odometer. Okay. Remember our JOP trick. JOP and then tab. JOptionPane.showInputDialog. How many miles on the odometer? Okay. Store that in a string. String str odometer equals JOptionPane.showInputDialog. Now, odometer is also an int, so we'll say convert from a string to an int. Okay, int odometer equals integer dot parse int and str odometer. Remember, integer dot parse int, double dot parse double accepts a string. In the case of integer parse int, returns an int data type. Double dot parse double accepts a string, returns a double data type. Okay. Set this value on the vehicle. Okay. int odometer. And there we go. So I'm going to save. I have a much longer method now. Actually, I'll also put a comment here. Print the my vehicle state. Okay, save. And I'm going to run, and let's see what happens this time. How many gallons of gas? We'll do something different. We'll say 20. How many miles per gallon? We'll say 10. How many miles on the odometer? Let's say about 100,000. And we see now the vehicle state is the data that I entered. So I have input. Input comes from the user. And we have output. Output's what's printed to this line here. Okay? Lots of good information there. Lots of good information. One thing that's pretty neat is I can click once on a line and it turns pink. And then instead of choosing run, I can choose debug. And it actually lets me watch this work one line at a time. It's a way that we can peek in and watch this work. Now to execute a line, I choose F6. Okay. Oops, sorry. Sorry, forget that. Um, I was thinking Eclipse. Eclipse, it's F6. NetBeans, it's F8. To watch a line execute, I choose F8. There we go. And then this green line is going to follow me, and every time I hit F8, the line that's green is going to run. So see here, it's going to pop up a JOptionPane and say how many gallons of gas, and this time I'll say 15. Okay, now it's going to create a new variable of type DBL, of type double, called DBL gallons of gas. It's going to take that string that I entered, convert it to a double, and now it's going to assign that value to the myVehicles object, and then prompt me for the next item, which is how many miles per gallon. We'll say 20, yeah, let's say 26, that's fine. Okay. F8, again, allows us to watch line by line as this executes. I choose F8, and that takes the green line and executes it and moves to the next. How many miles on the odometer? Let's say 36,000. Okay, F8, 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 F8. That's a quick look at the debugger. When I'm finished, I hit this red box. That's a quick look at the debugger. Unfortunately, you have to see the debugger about 3 times before it makes sense. As a matter of fact, you have to use it, get frustrated, give up, and swear you'll never use it again about 3 times. But do it. Stay persistent on that. Because I assure you, learning the debugger will save you a lot of time in a programming course like this and all courses that follow. As a matter of fact, when I teach Computer Programming 1 and in the next quarter teach Computer Programming 2, I always ask the first day of Computer Programming 2, first of all, I ask people what's confusing about number 1 that they'd like me to cover again. Secondly, I will ask my former students who took me for Computer Programming 1 to tell me, or to tell the people who didn't have me, give a hint. What is a hint that will really help you out in this class? And the answer is almost always learn the debugger. So we've just taken a brief look at it right now, and I don't expect you to understand it well yet. But we're going to continue to use this debugger throughout the quarter, and we'll see how it will help us find logical errors that happen in our program. So that's the debugger, and that's also interaction from one class to another. Okay, notice that when I want to alter the state of the other object, I'm always calling setter methods. And it seems like a bit of a waste because all the setter is doing is it's taking this parameter variable and assigning it to the attribute. Why can't I just assign the attribute directly? Well, the attribute is private access, and that means it's only visible from within this class. Things that are public are visible from outside this class. So proper rules of encapsulation means that attributes should be private and methods that are getters and setters should be public to allow access to those attributes. It sounds kind of funny, but again, if you're going to stick with this as a career, that's something that you're going to want to know because it's going to come up in an interview. So let me give you an analogy that will explain this a little bit better. Here's an analogy from nature. I mentioned that I have an interest in horticulture. And this is my old neighborhood where I used to live. And these photos were taken by Google back in summer of 2007. The reason I know that is we had a tremendous drought that summer. And a lot of plants died. Now, if you know anything about plants, what you think about what makes them green. And when we think green, we tend to think chlorophyll. So that is correct. That's what makes them green. Well, we look at this tree, and we see it's green at the very top. Okay, and all these trees have green all over, but definitely at the top. The chlorophyll is basically a solar cell that converts solar energy into power, basically. And to do so, it requires the element magnesium. Now, Magnesium is not available in the air. If it were, we would breathe it and die. It's only available from the ground. So somehow the magnesium has to get from the ground up into this tree canopy. And the question is how? And it's simple chemistry. It's a matter of water pressure. We'll see how in just a moment. But first, take a look and see if, there I go again. It's a little hard because I have the screen capture software right on top of Google Maps. Take a look and tell me if you see anything, any theme among the dead plants and the living plants. And it's not 100% correlation, but this is a good example here. All of these are dead. They died in the drought. These are alive. Now, one thing is these are a lot younger, but another thing is these are all evergreens, and these are deciduous. Okay, now think to yourself, what's an evergreen? Think of a pine tree. Have you ever seen a pine tree wilt? Have you ever seen pine needles wilt? Now think about a deciduous tree or something with leaves. Have you seen that wilt? Probably you have. And that wilting mechanism is a protection mechanism for the plant. What happens is this. Plants have stomata. Okay, I'm going to go to image search here just a second. Actually, that'll work. Plants have stomata, which are these valves that sit on the leaves. Okay, and go to images. So stomata are valves that are on plant leaves. And what they do, when a plant has enough water, the stomata open and they let out water vapor. That water vapor causes suction, and that suction pulls water up from the ground into the tree canopy if it's a tree. That's how magnesium gets into a tree canopy to create chlorophyll. The stomata open up, it lets out water vapor. That water vapor leaving creates a vacuum. The vacuum pulls up more water from the ground. Now, there's a problem here. What if there's no more water in the ground? If that happens, then this vacuum stops and the plant essentially dies of thirst. So that's what wilting is. What wilting is the plant is closing all of these valves and saying, I can't let water out. Plants that wilt have some degree of protection against drought because they will close their valves and they will shut down this water circuit and they won't lose water. They're going to protect themselves. The only trick is this only works in plants that have these valves. It only works in plants that can wilt. In other words, leafy plants. If you think of an evergreen can't wilt. So its valves are essentially permanently open. And in the drought of the summer of 2007, the evergreens were hit especially hard because most of their valves were stuck open. Now, what in the world does that have to do with programming? Well, that's what encapsulation is. Encapsulation is our stomata. These are our valves. So, in the normal course of business, we can keep them open and give access to our internal data. Okay, but if we need to shut off access to that data, there's exactly one point of entry and exit, and that is our getter and setter, which is our stomata. That's the way that we can protect our internal data. Okay, so in other words, we can do things like in set odometer. We can make sure that the user has passed in a valid value. If not, we throw back an exception and say, I can't accept this value. The only place where odometer can be altered from outside this class is this method. So by having one point of entry and exit, we're able to better control the data coming in and the data going back out. And that's essentially what encapsulation is, a very important term in programming. Okay? So encapsulation, a very important term. Another thing that we've seen today is this ability to access methods from a different class by constructing an object of that class and storing it in a variable of the same type, and then using that variable to invoke methods. It's very important. If you're going to call a non-static method on vehicle, you have to do it on a variable of type vehicle. Okay? That's how it knows where to find that method. If I just said set miles per gallon without the my vehicle, it'll redline. because it doesn't know where to find that method. If we're accessing a method from a different class, we have to access it by having a variable of that class type and then a period and then calling that method. That's the only way that we can do that. Okay? So we saw encapsulation. We saw the ability to invoke methods on one class from another. Another thing we saw are the three different categories, not types, but the three different categories of variables. We have attributes which describe state. We have parameter variables which allow values to be passed into a method. And one we used but didn't talk about is a local variable. And a local variable is a variable like this one, which is declared inside a method and only used temporarily. So this variable is only used in the highlighted blue area. That's what we call a local variable. So if you're thinking of quiz question suggestions, a good one are, what are the three categories of variables? Not types, but categories. Attribute, parameter, and local variable. Another one might be, what does a parameter variable do? How do we pass a value in? Another good one might be, what is encapsulation? Another good question would be, tell me the parts of a method. We have the access modifier. Public means it can be accessed externally. Private means it can't. We have the return type. We have the method name. Optionally, we have the parameter list. Even if we don't have a parameter list, either way, we have parentheses. Then after that, we'll have an open and a closed curly that set the boundary for that method. So those are excellent questions for our next quiz. Think about that. Do quiz question suggestions. In our next lesson, what we're going to do is we're going to implement this go method, and we're going to put some mathematics in there where we'll take this int distance and we will do the math to actually add the distance to odometer and then figure out how much gas we've used and subtract that from gallons of gas. So that will be on our next recording. I'll post this on Blackboard. Thanks, and we'll see you on the next recording.